Thank you so much. Thank you. So happy to be here where I can finally be assured I can get a proper cup of tea wherever I go. I'm very happy to be here. Good afternoon. I'm Kalinowski, and I wanted to thank Global Innovation Forum, Max, for having me here, and also to Oculus and Facebook for letting me do what I love for a living. So for me, being an engineer didn't feel like a choice. For me, it was a calling. So when I was 5, my parents got me this little remote control car, and it was kind of a big deal. It was really cool. It went forward, back, turned, and they came downstairs. It was Christmas, and so all the presents were out under the tree, and they came downstairs the next morning and found this little car they bought me in a million pieces all over the ground. And they were not very happy with me for doing that. And so they vowed never to get me another remote control car or any fancy little toy like that. And but I wore them down. And a few years later, they got me this really cool Batman race car. And the lights would come on and the cockpit would open, and it made really cool sounds. And I lasted about 5 days before I took it all apart, because I just had to know how it worked. I couldn't help myself, and I still can't. I'm addicted to hardware. I need to touch and feel things with my hands. So today I'm the head of VR hardware for the AR/VR division at Facebook. I didn't take the job at Oculus because I loved VR. In fact, I thought this was just for gamers. But when I tried the prototype the first time, they'd just been acquired. And so I went down into this building next to mine, and they had this little room set up. And only a few hundred people in the world had tried this technology at that point. And I put it on, and I was entirely transported somewhere else. My mind really believed that I was in another place. And I knew then that this technology was going to be for a lot more than gaming, although it's really fun for gaming. I knew that it would be a big deal for travel, for medical, dental, that it would be, folks, you may have heard, but you could actually do modeling in VR that you can't do medically. You can't otherwise know how to do surgeries in some cases. So we have a lot of exciting things going on in VR. Who's tried actual VR in the audience? Oh, great. So everybody's pretty much tried VR. That's wonderful. So as a young engineer at Stanford, I actually struggled a bit. I was really privileged to be at Stanford, but I kept being frustrated because in my engineering degree, we were solving problems that had already been solved by somebody else before. And that was a bit frustrating for me. And so it was the machine shop at Stanford that kept me sane. I don't know if anybody knows what it smells like to be in a machine shop. The cutter fluid and all the little aluminum shavings around on the ground. This is actually, fast forward, this is our machine shop in Oculus and Facebook. But that's really what kept me sane. And also, the idea of making the impossible possible is what's guided my career. Looking back, I actually never really picked companies. I picked products. And the way I guided my career was doing things that nobody else has done before. The world's first ultra-mobile PC, the first laptop machined out of a single billet of aluminum, and taking the first VR headset to market. I've learned that the secret to making really great products is actually focusing your and your team's energy on the right things at the right time. But in order to do right in the world, you also have to be able to determine with some certainty what the right things are. Working in tech has taught me that good intent is not good enough. And as our rising consciousness begins to catch up with this speed of innovation, we have to find ways to ensure that the products we design and make aren't doing more harm than good. So today I want to share a few rules for making great products that reflect my perspective as an engineer, a leader, and a community member. So historically, I've shared these rules in the context of product design. And I'll do that in a minute. I'll get to that. But in thinking about my comments here today, I realized that before I accept a job, it's also my responsibility to determine whether the product I'm about to build will have an impact that I can stand behind. So if you find yourself at odds with the goal of the company you're working for, you can't compromise on that. This is the biggest non-negotiable for me. Once you've determined you're in alignment, you can focus on the product at hand. And there's this incredible, very special moment before you start a product where your stakeholders aren't clamoring, your boss isn't asking what's going on, you don't have any pressure. This is a very precious moment, because in this moment, you don't have any deadlines, and you can actually set out the future of what this product is going to look like. And that's what this rule is about. It's about which goals you won't bend or budge on no matter what happens. So before starting, it's about defining what your product absolutely must do before you ship it. So this was my first product, the OQO Model 2. Does anybody remember it? One gentleman here. Okay, there's a reason for that. There's a reason for that. Okay, so I started this product in 2005. And OQO was an ultra-mobile PC in 2005, before smartphones, that weighed less than a pound, ran Windows XP. It was about this big. It had a screen that rolled up, a Wacom tablet. It had EVDO modem, a full keyboard, and a number keypad. Pretty incredible product, actually. But there were some perfectionists at the company, and it was never good enough for them. And actually, that housing right there, we ended up having so many revisions in CAD and computer-aided design that we rolled over to a new part number because we had more than 100 and there were only 2 digits. That's what I'm talking about. And once the perfectionists were happy, it shipped in April of 2007. Does anybody remember what else shipped in April of 2007? What? The iPhone. That's right, the iPhone, which was a category killer for the ultra-mobile PC, because now you had apps very soon after. And we were late, and we missed, and the company went under. So new companies are often under a ton of pressure to ship things, to improve things, but they don't always do this non-negotiable thing very well. Sometimes they do it, but they usually change their minds when the rubber hits the road. Or they ship early, or they delay for the wrong reasons. You have to boil things down to the essentials. If you don't nail the critical features and the critical experiences from the beginning, then you don't make the right trade-offs as you go down, and you're not going to ship at the right time. And Steve Jobs had this idea for a lightweight book in the early 2000s, the iPad. They kept bringing him prototypes year after year after year, and they were all too heavy, because if you held up a book, your arms wouldn't get tired. If you held up an iPad and it was 2 pounds, it wouldn't work as a book. This was his non-negotiable. And it took them 7 years of internal work before they actually shipped the iPad. And the iPhone was discovered in the process, halfway through that process. But they didn't ship the iPad until they got it right. So that's my first rule. My second rule, you need talent, both fits and misfits. So this is a really important rule for me, because you can't achieve greatness without the right people. And you can always look at this group of people, the buttoned-up folks, the folks that you might find first on LinkedIn, and say, hey, if you're shipping impossible products, you actually want these folks there. You want people who've done it before. But what if you've never done it before? What if it's never been done? Then having only these folks in the room can actually be a detraction. Instead of having these folks, you might actually want somebody who builds robotics in his basement and maybe plays in a metal band. Someone like that. Somebody actually like my friend, Colleen. Colleen Henry works at Facebook, and she's incredibly brilliant. She's one of the best video encoding engineers in the world, but she might not look like somebody you'd want to find on LinkedIn to do this job. But has anybody seen the Silicon Valley TV show? Okay, they call her when they have a screen come up with a video encoding thing, and she tells them what to put on it. So that's Colleen, and she's really incredible. So when we started with the Rift, no one in tech at all had the fabric experience that we needed. Didn't exist. Why? Because underneath the fabric of the Rift, the very first Oculus Rift, there were infrared LEDs, and this is how we could know where the product was in space. The LEDs are always kind of glinting, but they're infrared, so you can't see them. And they have to go through the fabric because we don't want our customers to see these kind of ugly LEDs. So what that meant is we had to understand the transmissivity, the infrared transmissivity of this fabric and many others to decide what kind of fabric to pick. But nobody had that in a database somewhere. Nobody knew how to do that. So we ended up hiring a guy who both had fabrics experience, but also a high-tech background. And we found all the kinds of materials we thought could work and then ran them through a design of experiment to measure this transmissivity. Because if a piece of fabric meant that you could not see the infrared off angle, then we couldn't track the device. And so that was a really interesting learning for me, is that you couldn't find somebody who existed in the industry in fabrics, for example, to do this. On Rift, we learned a lot about iterative decision making. We wanted to make the walls between these big disciplines like soft goods and high tech more impermeable. We learned a lot about the fact that linear serialized decision making wasn't going to get us there fast enough. We were in a race actually to ship the first VR headset in the world, which we ended up doing. The only way we could do that is unserializing, parallelizing the development. Now, the Rift has laptop elements. It has screens. It has all these pieces that you'd normally find in a laptop, but it lives on your face, and you have to track it to a sub-millimeter precision, and the timing has to be sub-millisecond. Nobody'd ever done that before. If we'd kept the project work in silos, we never would have gotten the Rift out in the time frame we did. And the Oculus Go, this was the first mobile VR headset, really, at mass production. And it didn't have the same number of degrees of freedom as the Rift. It was only 3 degrees of freedom. But you could watch a Netflix video on what seemed like a 108-inch display. Very, very cool technology. And it was mobile. No phone needed, no cables needed. No one could make this 3-dimensional soft foam you see there, covered with the breathable fabric we required. They couldn't even figure out how to make the shape in high tech. But the most sophisticated people in wearable fabrics actually made undergarments. And that's where we went. Beyond expertise, this execution is really undervalued. And that's where we figured out how to make this part. Now, this is the newest product we just came out with, the Oculus Quest. And when we shipped the Quest, we made 6 degrees of freedom immersion mobile by creating this new inside-out tracking architecture. So it had cameras on the headset looking out and using several sensors in both the headset and controllers. The exciting thing about this product is, unlike the Rift, you don't have to plug it into a PC, but you also don't have to set up sensors, 3 sensors around your room. It does it all automatically. I also want to note quickly that when it comes to talent, diversity is really good for design, especially when you're designing high tech that wears on your body or your face. You have to take into account things like hairstyles or makeup. We designed the Oculus Rift and targeted the 5th percentile female and the 95th percentile male. And just in head sizes, the difference is kind of amazing. A 5th percentile female head's about this big, a 95th percentile male head's about that big. And we don't want to sell different SKUs for different sizes. We want to sell one product. So having a wide range of people in the office to actually test and try the product was a critical part of our success. But even more critical was making sure that those design engineers and industrial designers that came up with the product in the beginning were diverse. That's a much better way than just having 6 months of work and having somebody, oh, let's try it. Let's have somebody with a high ponytail try this, for example. Because if we only let certain people design our products, we actually get the products that only those people want. So ensuring that people with different backgrounds, perspectives, and experiences are at the design table will make your product more appealing to the masses. Next rule, let the product drive your style. So there's 2 main things to consider here, speed and caution, and you can't get both. Map out your approach to prototyping by determining your point on this speed caution slider. So which way you tilt will have a lot to do with how many are you making. Are you making millions of products like the MacBook Air? You probably have to be a little bit more cautious. Or are you the first headset for VR for consumers, you can probably be a little less cautious because you don't have volumes. Your volumes are still quite manageable in the very, very beginning. I can move faster on the right, but I may take on more risk. And let's think of a medical example, a medical product. You really want to be all the way over on the left, on the caution side. Not only for regulatory reasons, but you have an obligation to your customers to make sure your products are safe. And what does that look like on the caution side? It's about checking and rechecking your assumptions. It's empowering the people you work with to question each other. It's about making sure that a year in, they don't change the material on one of your parts without telling you, which actually happens kind of a lot. On the right side, we kind of let things go. We're not quite as tight on all these pieces. So your management of your team should also shift accordingly. If speed's the top concern, what I often do is I'll have a lead person write down all the things they want to work on and all the things they want to fix, and then I'll rip the paper after the top 5 because we just won't have time to get that far down the list, which usually alarms them quite a bit. So once you've figured out your place on this speed caution slider, you're ready to start building prototypes. The next big thing to think about is how you can iterate as much as possible before the ship date. So rule 4, start with the hardest problems first. So trust me, if you take a typical engineer, show them a problem and say, I'm not sure if this is possible, they're usually all in. My former colleague, Doug Field, who ran engineering at Tesla and is actually now back at Apple, had a very useful way to think about design effort. And this is what he said. So this is I'm going to clear this slide so hopefully folks over there can see me. On the x-axis is time, and on the y-axis is effort. And what most people do is the red line. Most people actually start with the stuff they know. And I'll give an example, presentations. I give a lot of presentations. The first thing I want to do is get in and start making slides, because that's fun, and I can pick my fonts, and I can line everything up. That's the worst thing to do, because that's me being on the red curve. Me being on the green curve would be like, hey, what should I talk about? What would I like to impart to these folks today? And then writing things down and then making the slides. But we don't do that very often. Most people do this wrong. Big companies and small companies actually do this wrong most of the time. On the green line is what is the hardest problem to solve in the product? What is something we're doing that nobody else has ever done? What is something that we're not even sure is possible? And you start iterating on that first. And then at the end, you can start working on your slides, which you can usually catch up on if you need to. But if you don't get those first hard things right, sometimes you add months or even years to your schedule. So take one thing at a time with your prototypes. That's another thing. A lot of people want it to look great and work perfectly, and it takes a really long time to get there. Actually, it's much better to separate those two things. Make one set of prototypes for how it's going to look, make another set of prototypes for how it's going to work, and you can combine them later. Next rule. Build ugly prototypes. And I'm serious, make ugly prototypes. So if your early iterations aren't hideous, at some point, some executive is going to see it and be like, that's what I want, and fall in love with it. Or you might do that. At one point, the controller for the Oculus Rift, the Oculus Touch, was literally a tube of plastic with putty on it. That's one of the first prototypes. When you're focusing on the toughest engineering problems first, you don't need to worry about how it looks yet. Don't give people anything to anchor to until you're actually ready. People do that, and it's detrimental to the process. You want to add polish when you're selling something. And a strategy for guarding a product's potential is actually keeping your prototypes ugly for longer. Braid in other ideas as you progress. You don't need to do everything at once. With the Oculus Touch, the team actually started with a general shape that was ergonomic and trackable. Here's actually the prototype of one of the later phases. And then once that was close, we moved to details around input. The electrical innards and sensors were split off into a separate group of prototypes. And then once we got far enough, we actually combined them to prove that everything could fit. Converge quickly or reset. This principle keeps you from going down the wrong path for too long, and it has to do also with listening to your team. Too much prototyping can actually be a bad thing. You can sense when you're on the wrong track, when your iterations start to yield these tiny incremental improvements, and you aren't converging towards your goal. Either change your goal or change your assumptions. Scrap the plan, back up, and find a different way to solve that problem. Has anybody ever waited too long to rip off the Band-Aid on one of these? It hurts more when that happens, actually. So there we go. The Mac Pro, when we were working on the Mac Pro at Apple, so folks, the actual outside is pretty cool. It's an impact extrusion, like the way they make a Coke can on the right. And on the left side, it's an extruded part. And the middle of it is a heat sink that's extruded. And the outer on the left is the housing. And originally, industrial design at Apple wanted the inner and outer on the left-hand side to be the same exact part. And we found like the best possible extrusion vendor in France. And we worked on this for years, and it didn't work. In the end, we couldn't actually extrude the inner heatsink with the outer part. It's just started to fall apart. And this is an example, I think, of doing too many prototypes down the wrong path. And luckily, Matt Casebolt, who I was working for at the time, made the call to just stop and do a reset. So if you're not converging, you need to make that call. So here's a slide where basically every iteration on the bottom, you should get closer and closer to your goal. But if your goal is along the top and you're finding yourself on this red line, where every iteration you have smaller and smaller improvements, that's when you really need to stop and check yourself. You need to actually decide to go backwards and either change the goal or change the solution. And sometimes one or the other is the right thing to do. As a leader, too, you can improve your team's willingness to give you this information. If you improve your response to bad news, your team will index a lot off of that. And so you need to train everybody that if there's bad news, come share it. We'll work together to solve it. Also, engineers like me, we have a really hard time not having things perfect. And so it really helps to say, hey, we're going to get this perfect in the next product, and you can work between now and then on that, but this product needs to ship. That can take the sting out a little bit. Ending your iterations too close to your ship date is really dangerous because of all the interdependencies, especially with something like hardware or product. So before you make any changes, before you go back, remember to revisit your non-negotiables and prioritize. Otherwise, you can end up causing more problems than you're solving. The small changes could break the whole thing. Iterate like crazy. My favorite rule. This is how you get from good to great, even if everything else is done perfectly. Look, you can have the perfect on paper price, the perfect set of features on paper, the perfect display resolution, whatever it is. But if you don't iterate on the tiny details of the things that people touch the most in your product, you won't make a great product. One example is the trackpad on the MacBook is glass. And it took more than 50 iterations of the chemical etch of the glass to get the texture right. And has anybody ever gone from a newer MacBook to a non-Apple trackpad, like a different laptop or something? You probably know what I'm talking about. It doesn't feel right. Either it's too glossy or slippery, or your finger doesn't glide across it right. And that's the kind of iteration that took that trackpad from good to great. Or my favorite example, the moment you step on the train in the Zurich airport, and it just whisks you away silently to Zurich. The train is so quiet. And it took somebody so much work to make that train quiet, because trains naturally want to be fairly loud. Most trains in the world aren't quiet. But when you come around the bend to a view like this, the synesthetic sense is so much more powerful. The level of iteration and the commitment to excellence makes all the difference. So here are my rules. The last one is actually that prototyping should be fun. If it's not fun, you're doing it wrong. You're either over-constraining your engineers or you're being too loose. You need to free them. And you have a grand excess of ideas. And so you can pick up the next great product from the cutting room floor. So a lot of people actually know these rules. These aren't really my rules. But a lot of people don't actually apply them consistently. You have to apply them rigorously. And if all else fails, go back to where you started. Why are you building the product? And who is it for? Stay focused on user experience, apply these rules rigorously, and go back to first principles if you get stuck. I believe it's because I've followed these guidelines that I'm lucky enough to be considered a leader in this field today. With that leadership does come responsibility. I want to use my influence on the next generation of products and the people who deliver them. So I have to think, how can I use my talents to help move the world in the right direction? So outside of my role at Facebook, I joined the board of Axon recently. The founder and CEO, Rick Smith, has publicly declared his desire to make bullets obsolete and his mission to protect life. And Axon makes a group of products, including the taser and the body camera for police officers. So I had my doubts when we first started talking. But we had a bunch of strategic sessions about reducing risk during school shootings. Axon decided to forego profits by refusing to add facial recognition to their devices. And that's really important because facial recognition is much more accurate in white people than people of color. So after these conversations I had, I started to consider whether my expertise could help reduce harm in our communities. In instances where police end up pulling their guns, when they meant to reach for their tasers instead, the look and feel of these weapons really matters. Body cameras are a critical way to ensure, certainly in America, that police are accountable and that community members can have accountability. And in VR, actually training for maybe the worst day of your life has already shown really interesting promise as a way to train first responders and people in really dangerous jobs like police. So the more accessible, frequent, and realistic de-escalation training is, the safer we'll all be. So I knew that becoming a board member would be jarring to some people in my community and at my company, but I also knew I could help ensure Axon's products were designed with communities as well as law enforcement in mind, that I could advocate for hardware with excellent reliability and reduced environmental waste and champion ethics-driven decisions. Accepting the role felt like one of my biggest decisions to date. I don't know if I can actually make our law enforcement and our communities safer. But one thing I do know is that when we are appalled by what's happening in the world, but too scared to engage, nothing actually changes. And that's a reality I can't live with. Can our approach to designing the next generation of products truly change the world? As with every piece of hardware, I truly believe the answer depends on who's building it and how they execute. Thank you.